Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our fifth lesson on vectors, whereby we are looking at a past Kcse question done in 2012, paper 2, question number 19. So it is our fifth example, which reads that in triangle OPQ below, the vector OP is P, of course it's already indicated, then the vector OQ is Q, which is also indicated. Then you are told that point M lies on OP, such that the ratio of OM to MP is given as 2 to 3. So the direction of our ratio is from point O towards the point P, which is the same as the direction of the vector OP. So of course OM, we are given its ratio is 2, then the ratio of MP is 3. So this ratio is actually 3. The direction of the ratio is similar to that of the vector OP. Then we are further told that N lies on OQ such that ON to the ratio of NQ is given as 5 to 1. The direction of the ratio is from point O towards point Q, which is the same direction as that of vector OQ. Therefore, ON has a ratio of 5. So this one is ratio 5. Then NQ has a ratio of 1. So having indicated or interpreted the ratios, we can go to the working. So we are told that the lines PN intersect MX, that is MQ at X. So of course it's already indicated on the diagram. So part A of the question, part A Roman 1, we are told to express in terms of vectors P and Q the value of Pn. So the vector Pn in terms of the vectors P and Q will be given by, so we look for a root on the diagram for Pn that gives us a complete triangle that has known values. So the root will be PO plus ON. So this will be vector PO. Then of course we are going to add the vector of ON. So that should give us the vector Pn. So we are using the root of PO then plus ON, PO plus ON, which will be given by, of course we are not given the vector PO, instead we are given the vector OP. So we know that PO is just the negative of OP, so this will be the negative of vector OP because of the change of direction. So PO is moving downward, then OP, its direction was upward. So because of the reverse of the direction, hence we introduce the negative, then plus the vector ON. Of course ON has a ratio of 5, then it's moving in the same direction as vector OQ, which is actually Q. So this will be 5 divided by the total ratio is 5 plus 1, which of course will give us 6 of vector OQ, of the vector OQ. So this will be given by the negative of vector OP, we are given as vector P. So this is the vector P. Then we'll add 5 over 6 of vector OQ, of course, which is given as a small vector Q. So if I start with the positive vector, I'm going to have 5 over 6 vector Q, then of course minus vector P. Then we move to Roman 2 of the question, whereby you are required to express the vector QM in terms of P and Q. So QM, the vector QM will be given by, we also look for a root on the diagram that gives us a complete triangle that has known values. So this is our QM, so the root will be QO plus OM, because if I use the root of QP then plus PO, of course this root I don't have the value of QP, that's why I'm choosing the root for QM to be QO plus OM. So this will be the vector QO, then of course you are going to add OM, QO plus OM. The other alternative route would have been QP plus PM, but I don't have QP, that's why I've settled for QO plus OM. So I substitute the values. So of course QO is just the negative of OQ, so this will be the negative of vector OQ. Then of course we are going to add OM. So that is, we are going to add OM. OM is moving in the same direction as vector P. so its ratio is 2, so this will be 2 out of the total ratio of that line is 2 plus 3, which is actually 5 of vector OP, of vector OP. Then let me separate my working here with a straight line this way. Then let me substitute the values that I have. So this one means that QM, the vector QM, will be given by the negative of OQ. Of course, OQ is vector Q, so this will be negative of vector Q. Then I'm going to add 2 over 5 of vector OP. Of course, OP is given as vector P. So if I start with the positive vector, I'm going to have 2/5 P, then of course minus the vector of Q. So that is 2 marks. Then we move to part B, Roman 1 of the question. So B, Roman 1, we are told that given that Px is K, Pn, and Qx is RQM, where K and R are scalars or simply constants, write 2 different equations or expressions for OX in terms of PQ, K, and R. So I'm going to have my first equation for OX, so I'm going to call it OX1, which should be given by, so the first root, we must use the first value that we are given. So the root must use Px. So on the diagram, I need to connect O and X so that I exactly see the possible roots that will give me the OX. So once I've connected those two, so I look for a root of OX that must pass through PX. So OX can be given by, so the root that uses PX will be OP plus PX. So this will be given by the vector OP, then we are going to add PX. So the key point is you need to use the given values here. We must use PX and also QX in the second root. So this will be given by, so OX1 is OP plus PX. So OP of course is vector P, which is given on the question, then plus PX. I'm simply going to substitute what I'm given here, which is K PN. K P N. So this is KPN. Then of course vector Pn, I've already computed it in A Roman 1. Therefore if I substitute, I'm going to have vector P, then of course plus K into vector Pn. I had already gotten it in Roman 1 as 5 over 6 Q, then of course minus the vector P. So if I open this bracket, I'm going to have vector P, then of course plus 5 over 6 K, then of course minus K vector P, minus K vector P. Then let me separate this with a line so that we move to, that is OX2. So this is our OX1. Of course we can combine the similar vectors. This was actually 5 over 6 K, that is K vector Q. There should be a Q here, vector Q, then of course minus K vector P. Then I want to combine the vectors P and P so that I'm going to have the following. So this should give us the following. So I'm going to have vector P, I combine it with negative K vector P. Then of course after that I'm going to write the 5 over 6 K vector Q, 5 over 6 K vector Q. So if I combine the values, the coefficients of vector P, I'm going to have the following. Of course it means the coefficient of P here is 1. So this will be into bracket 1, of course minus K, 1 minus K. So this will be 1 minus K of vector P, 1 minus K vector P. Then I'm going to add plus 5 over 6 K vector Q. So that if you open this bracket, you will still come back here, because 1 times vector P, you'll get P. Then 1 times negative K, you'll get negative K. So that is our OX1. Then we also need to find OX2. That is the second equation for OX2. But in this equation, we must use the root using Qx. So on the diagram, the root that uses Qx will be OQ plus Qx. So this should give us the vector of OQ. Then of course we are going to add Qx, which will give us vector OQ. We are already given as vector Q, then plus Qx. We are told that it is RQm. So this is RQm, of course, vector, which will be equal to the vector Q plus R into bracket. We need the value of Qm. We have already computed for Qm, of course, which we got it in part A Roman 2. So we got it as 2 over 5 vector P, then minus the vector Q. If I open this bracket, I'm going to have Q, then plus 2 over 5 R vector P, then of course minus R vector Q. Then I can combine the vector Q so that I'm going to have the following. Here the coefficient is 1. So if I combine this term and this term, I'm going to have 1 minus R, then the whole thing into bracket vector Q. Then I'm going to add 2 over 5 R vector P, 2 over 5 R vector P. Then so those are the two equations for OX1 and OX2. Then in Roman 2, they want me to find the values of the scalars K and R. So the values of K and R. So this is Roman 2 of part B. So this is B Roman 2. For me to find the values of the scalars K and R, I'll simply equate OX1 and OX2. So if I equate these two, I'm going to have the following. My OX1, I got it as this one, so it is 1 minus, of course it is under bracket, 1 minus K vector P, 1 minus K vector P plus 5 over 6 plus 5 over 6, that is KQ, 5 over 6 KQ, which should be equal to OX2. I've found it as this one here, which is into bracket 1 minus R, 1 minus R vector Q. Then of course I'm going to add 2 over 5 R vector P, R vector P. Then I'm going to equate the coefficients for specific vectors. So I'll start with P. So equating the coefficients of vector P, I'm going to equate the following. So here the coefficient is this one here. Then the coefficient for P is 1 minus K. So equating the coefficients, coefficients of P, that is vector P, I'm going to have the following. 1 minus K will be equal to 2 over 5 R, 2 over 5 R. If I make K subject of the formula, I'll take K to this side, then 2 over 5 R to the other side. Alternatively, I can also use the elimination method to solve this. So let me do away with the fraction. So I multiply through the LCM. LCM is 5. So I multiply this by 5. I also multiply it by 5. I also multiply this by 5. So that I do away with the fraction. So I'll remain with 5. Then of course minus 5 K, which should be equal to, the 5 and 5 will cancel. So I'll remain with 2R. So I'll take the negative 5K to the other side, so that I'm going to remain with 5 being equal to 2R, then of course plus 5K. Remember, I want to use the elimination method. That is why I'm doing away with the fractions. Then we also need to equate the coefficients of the other vector, of course, which is going to give us the following. So equating the coefficients, equating coefficients of the other vector is Q. Equating the coefficients of Q, we are going to have the following. So the coefficients of Q, we have this one here. Then on the other side we have 1 minus R. So this should give us 5 over 6k, which should be equal to 1 minus r. Then I do away with the fraction, so the LCM is 6, so I multiply through by 6. I also multiply this by 6, I multiply by 6, so that 6 and 6 will cancel out. So I'm going to remain with 5k, which is equals to 1 times 6, I'll get 6, then minus 6k. This should be actually 6r, so this is 6r, so it will give me 6 minus 6r. So if I take I want to combine this, I'll take this to this side, then negative 6 should move to the other side, so that I have negative 6, which should be equal to, I'll start with negative 6r, then of course minus 5k, So this will be my second equation. So this is my equation Roman 1. Then the other one, this is k. So this is 5k. So this is my equation Roman 2. So I want to solve equation Roman 1 and 2 using elimination method. I want to use the elimination method to solve those two. So using elimination method, I'll simply rewrite the two equations. So I'm going to have the following: 5, equation 1 was 5, is equals to 2r, then plus 5k. Then equation 2 is negative 6, is equals to negative 6r, then minus 5k. So the easiest term to eliminate here is k. So if I want to eliminate k, I'll simply add the two equations. So that positive 5k plus minus 5k, I'm going to get 0. Hence, I eliminate k. Then 2r plus minus 6r, I'm going to get negative 4r. This will give me negative 4r. Then 5 plus minus 6, I'm going to get negative 1. Because it's the same as saying 5 minus 6, which will give me negative 1. So, of course, here is plus 0. So, I'm having negative 4r, which is equals to negative 1. If I divide through by negative 4, I divide through by negative 4. It simply means that my value of r will be equal to a quarter. Because negative divided by negative, you'll get a positive. Then I substitute in one of the equations so that I can find for the value of k, so that I'll have the following. So I want to substitute in equation Roman, I can use either Roman 1 or 2. Let me use equation Roman 1. So I simply substitute where I have r, I substitute with a quarter. So this will be, equation 1 will be 5 is equals to 2r, but of course my r is a quarter. Then of course I'm going to add, so it is 2r plus 5k. So plus 5k, which will give me 5 is equals to 2 multiplied by a quarter, you will get a half, because 2 will go into 4 2 times, then of course plus 5k. So this is going to give me the following. So I'm going to get the following. So this will be 5k. So 5k will actually be equal to 5 minus a half, which I'm going to get as 5k is equals to. So if I compute, if I take 5, then of course minus a half, I'm going to get the following. So into improper fraction, it will give me 9 over 2, or simply 4.5. So this gives me 9 over 2. Then if I divide through by 5, I also divide through by 5, I'm going to get the following. So my value of k will actually be equal to 9 out of 2 by 5, I'm going to get 10. So my k will be 9 over 10. So those are the values of k and r. Then we move to Roman 3 of the part B. So in Roman 3, we are told to determine the ratio in which x divides mq. So it means if it is x that is dividing, it means x is in between m and q. Therefore, it means that if we consider that line, the line should be this way. If m is here, x should be in between, so that q should be on the other side. So it simply means that the ratio that they want me to find is mx2 actually xq. That is the ratio that they want me to find. But if I use one of the given equations, I was given in this part that qx, I was told that qx is equals to rqm. But I've already computed for the value of r, therefore I'm going to have qx, which is equals to, the value of r was a quarter, so this is a quarter of qm. If I divide through with qm, I also divide the other side with the qm. Then of course qm and qm will cancel out. So this one means that the ratio of qx to qm will actually be given by 1 to 4. So that ratio is 1 to 4. So if this is our line, it means qx, this ratio is 1, then qm is the whole line, which is 4. It means the other one is 3. So that when you take 3 plus 1, you will take the total, you will find the total ratio of qm. So on the diagram, if I indicate the ratios that I've found, the ratio of qx, I've found it to be 1, then of course mx will actually give me a ratio of 3. So that 3 plus 1, you'll get a total ratio of actually 4. So the question wants the ratio in which x divides mq. So this ratio will be, the ratio will be mx, mx2, xq. Remember, the dividing number should always be in the middle if it is internal division. But for the case of external division, the number will go outside. So we look at an example involving external division. So this will be, the ratio of mx is actually 3, as we can see on the diagram. So the ratio will be 3, 2. Then the ratio of qm, so that is xq, this ratio is actually 1. So xq is 1. Therefore, the ratio in which x divides mq is actually 3 to 1. So in the next class, we'll be looking at further examples on vectors. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy.